Okay, folks. So last section here. So we are in section 3.6, which is the inverse and the contrapositive of conditional statements. What a title. Good Lord. Red. All right. So, this is where we are just going to add in just a few new concepts here. So first off, no, you know what? I'm going to do definitions first here. So we're going to start out here we have something called the inverse, and you may have heard me mention this before. But an inverse is a statement that is formed by negating, which I will talk about. Don't be shocked by the word. Both the hypothesis and the conclusion of a conditional statement. For example, if the statement is if a number is even, then it is divisible by 2. The inverse is if a number is not even, then it is not divisible by 2, right? Negating is doing the opposite. Now, we're going to take it even one step further here, which is the contra positive. Now, this is a statement that is formed by negating both the hypothesis and the conclusion of the converse, which is what we learned about up here, right? What's the converse? The converse is when you switch them. So, for example, for this one, if I give you the regular statement of if a number is even, then it's divisible by 2. The contrapositive is if a number is not divisible by 2, then it is not even. So what it does is um so for this one, you basically add not before the statements. I promise that this will make more sense once I give you some examples. You'll clue into this. The contrapositive, um, do I want to deal with that now? No. All right. Starting out here. If I give you a statement, right, is just if P, then Q. Now, the converse, let me do this to organize this a little bit. The converse here is the reverse of it. So doing a converse is reversing it, right? Again, you got to refer back to your notes. All you do is you swatch it around. So reverse it. If Q, then P. And again, we'll give you some real world examples here to kind of clue into this. Now, the inverse, right? The inverse is I'm going to do the opposite. Okay. So if not P, then not Q. And if you're wondering, well, how do I remember this? How do I memorize this? This one has an I, this one has an I. Is really the only thing I can do to help you out between the difference between converse and inverse is look for the I's. Okay. Because a lot of people that where you're going to make a mistake here is you're just going to mess up the terminology of it and do the wrong thing. So the contra positive here, again, you're going to negate the converse. It is an converse and an inverse. Okay, so I'm going to negate the converse. The statement is this. The converse of that statement is this, which means the contrapositive is take the inverse of the statement, which means if not Q, then not P. Okay, I hope that makes some sense here. I know it's a lot. The only way you're gonna learn it is you're just gonna have to flip back every freaking time you see the word until it's just engraved in your brain. Um, okay. So we have some new terminology for this. You know what? Actually, before I even get into that, though, just gonna do that. Save yourself some time here. Um, so I got some new. Oh my gosh, go away, go away, go away. There we go. So I have some new um notation for you, which is this bad boy here. Got some notation here. So I really want to draw your attention to this bad boy here. So normally in a conditional statement, you have P arrow Q. For an inverse statement, how do instead of having to write inverse P, inverse Q, that will get annoying. Mathematicians are lazy as hell. So we use, and I don't even know the keyboard like for it, we use this. The inverse of P leads to the inverse of Q. Okay? So what would the contrapositive be then? Actually, you know what? Before I even go into that, the converse here would be Q leads to P. So what is the contrapositive? How do I find the contrapositive? I do the inverse to the converse, or I converse the inverse, right? So I'm gonna inverse the converse in this case, right? Which would be the inverse of Q leads to the inverse of P. So I hope that makes sense on how this notation works. When I give you some real examples, you'll do a little bit easier with it, okay? All right, contrapositive. Yeah, okay. Here we go. Oh, nope. Oh, come on. Yeah, hunk of junk. There we go. Cool. All right. So, um, let's do example one. I'm going to mix it up here. I'm going to go example 1 to 3 is what I wanted to do, if I recall correctly. All right. So, we're going to do example one here. Oh my God. Which is verifying these statements. All right. So we're going to verify these statements. I'm going to do this down here. Okay. So, consider in the following conditional statement. If today is February 29th, then this year is a leap year. Now, if you don't know what a leap year is, hooray, Google! There's this stuff here. Now, if you don't really get this, this is not we're not testing you on your leap year stuff. So if this question confuses you, don't worry. Question 3 should simplify things a little bit here. So there we go. Okay. So question A asks us to 1, verify the statement, and then 2, disprove it. So basically, remember, when we say verify, is this true? Is this true always? Um, so to verify this, what we're going to do is we're going to draw a truth table. So I'm going to quickly draw a truth table here. Before I even do that. So if so remember it's an if then. So in this case, my P, which is my hypothesis, will be today's 29th of February, the 29th. My Q is this year is a leap year. All right, so doing a table here. Mm-hmm. I literally have a tool to draw straight lines. That. There we go. Good enough. So we'll say this is our P, this is our Q, and this is whether or not it's true that P does lead to Q. So if my P is true, for context, you're probably watching this in February. So you can see it ends on the 28th, right? This is February here because this is not a leap year. And again, you look at the examples here. Well, it's not divisible by 4. It's 2026. Can't divide that by 4. So right now, it's not a leap year. So if today is the 29th, that means that, well, it must be a leap year, which means it's true. So now what we want to do is we want to verify the inverse or disprove it with a counter example here. So for question B, so what's the inverse? Remember, the inverse is the opposite, right? So we don't change the order, we just add a not in front of it. You add a not before the statement. So instead of, so the inverse in this case would be if today is not February 29th, then this year is not a leap year. Again, in this case, the inverse of Q, right? You draw your little symbol, draw your little symbol. Oh, God. So we draw a little symbol here. So the inverse of Q is not Feb 29th. And the inverse of P, sorry, my bad. The inverse of P is not February 29th. The inverse of Q is it's not a leap year. So if we draw our little like table again here, I'll just freehand this now because we're getting lazy. What is it? So doom. So if I have the inverse of P, the inverse of Q, and then verifying whether or not the inverse of P does in fact lead to the inverse of Q. So is this true? So if today is not February 29th, so let's assume it's February 28th, then it's not a leap year. Um, and so like in this regard, what that really means, sorry, actually, no, this is false. Right, because again, if it's 20, it can just be, February 28th of a leap year, right? Maybe it's just literally not February 29th that day. Maybe it's March, maybe it's January, whatever it is. So in this case, this statement here is going to be false, okay? Because we have disproven it. It can be a leap year it can still be a leap year, but it doesn't have to be February 28th. There's still 365 other days of the year. Okay. So that's why that's false. I apologize for that one. So now let's do question C. Verify the contrapositive. How do I find the contrapositive again? You are going to take the converse and the inverse, or take the converse of the inverse, or take the inverse of the converse. So I already know what the inverse is. So I'm just going to take the converse of that. I'm just going to change the order of it, right? So the inverse was if today is not February 29th, then this is not a leap year. So what would the converse be in this case? Sorry, what would the contrapositive be in this case? If today is not, if today is not a leap year, sorry, is not a leap year, then it is not February 29th. That would be the contrapositive here. This top sentence doesn't need to exist. This is just me giving you that visual reference. All right. So, and again, thinking about this is true. You don't have to draw the table in this case. Like you can just kind of use common sense. So if today is not a leap year, then it is not February 29th. So if it's not a leap year, which is true, then that means you're right. It cannot be February 29th, which means the statement is true. So let's give you some other examples here. So let's say I'm going to do a conditional statement, and then I'm going to give you the contrapositive statement of that. So this isn't so we're done with that question there. Again, if you're like that makes no sense to me, this will help you out. Okay, so the conditional statement here is if you are in space, then you are not on Earth. So that's the conditional statement. So what would the contrapositive be? Remember, you got to flip it. So, if you are not on Earth, don't write this down yet, then you are not in space. So that I flipped it, but now I still got to take the inverse of it. Now, so I got to put a not in front of everything, right? Sorry, I put it in there. So what's the problem here? Not. You don't do that. It's just if you are. So instead of if you are not on Earth, no, that just means you are on Earth. So if you are on Earth, then you are not in space. That would be the contrapositive of this. If it is minus 40 outside, then water outside will freeze. That's a conditional statement. What would the contrapositive be? Pause the video, try it out. 3, 2, 1. So again, first you flip it, then you add the not. If water outside will not freeze, then it is not minus 40 outside. Now that's a contrapositive. You would then verify it as to whether or not that's true. And for something like this, hey, this one seems true, right? If you are on Earth, then you're not in space. That's correct. However, if water outside will not freeze, then it is not minus 40 outside. This one's kind of weird. It depends, because what if it's like, well, it's minus 30, so it will freeze. So this one here is false. Again, you have one example to disprove it. Okay. I want to go to question 3 here. So this one's going to be kind of hard for you because you don't have colored pencils and stuff. So you're going to have to instead just refer to your textbook. So you're not going to be able to, maybe leave a note here that says something like refer to page 212 because you're not going to have the wheel. So this one here says that Arizona is studying the color wheel in art class, and she observes the following statement. If a color is red, yellow, or blue, then it is a primary color, right? And you can see here it says that blue, red, and yellow are listed as primary colors. And then how do you get a secondary color, such as orange? Well, you mix two primaries, right? You mix yellow and red, you get orange. We know that. Well, then how do you get a tertiary color, like a more yellowish orange? Well, then you mix your secondary color with a primary color, and so on and so forth. That's what this is saying. So first, write the converse of the statement. At this point, pause the video. You can do it. 3, 2, 1. So the converse here is if a color is a primary color, right? Because for converse, you do the reverse. So if a color is a primary color, then it is red, yellow, or blue. Now, again, it's not asking us to verify it, so I can skip that for now. Question B is write the inverse of this statement. So what's the inverse of if a color is red, yellow, or blue, then it is a primary color? How to take the inverse? I take the opposite of it. So if a color is not red, yellow, or blue, then it is not a primary color. Perfect. I've rewritten that. Now, question C asks us to verify that the converse and the inverse are both true. So let's start out with the converse here, right? Here's the converse. Here's the inverse. Sorry, my cat was puking. Where did I leave off? Oh, right. So here's the converse, here's the inverse. So we got to verify if this is true or not. Well, if we're looking at this, so if a color is a primary color, then it is red, yellow, or blue. Well, I can't see anything in here to disprove it, right? So this one is, sorry, be specific. The converse is true. If you assume like that so if we assume this, so if a color is a primary color, so if we look at only the primary colors here, then it must be red, yellow, or blue. So it's correct. Yes. So both Q and P are correct in this case. Now, what about the inverse? Now, the inverse, if a color is not red, yellow, or blue, so I'm looking at every other color here, except for our primary ones, then it is not a primary color. And that's correct. Primary is only listed under those three colors. So that means this is also true. And then question D asks us if Arizona's statement is biconditional. How do I establish that something is biconditional? Great question. You go and you look up in your notes. What was that from? That was from 3.5. Biconditional, right? So if a statement, so if you reverse that statement and it's also true, then it works. Right? So her statement was if a color is red, yellow, or blue, then it is a primary color. Now, is that true? Yes. What about it? So now let's reverse it. So if a color is a primary color, then it is red, yellow, or blue. That's also true. So the statement is biconditional. And you can see how she's done this here in like a Venn diagram. You know, kind of a nice way to learn how to like organize this. In fact, I'm just going to yoink that. I kind of like that. You don't have to draw this, but you know, again, it's a nice example here to really understand how that works. I like this one because it's numbers. Let's do example 2 as well. All right. So example 2 here is consider this. So if we want to consider the following conditional statement, if a number is a multiple of 10, then it is a multiple of 5. So now what you want to do is you want to write the contrapositive. What's the contrapositive? Great question. Your contrapositive is the converse and the inverse. Now, if it's easier for you, you can do the inverse and then do the converse of it if you want, right? So so let's do the inverse. If a number is not a multiple of 10, then it is not a multiple of 5. Now let's do the converse of this, which turns it into the contrapositive, right? Because remember, contrapositive is just taking the converse of the inverse. So how do you do that? Well, now you flip the order of it. A number is not a multiple of 5? Oh, number is not a multiple of 5, then it is oh, yeah. If it is not a multiple of 10. There's the contrapositive. Again, I just wrote this inverse here to help you out because sometimes you kind of struggle with doing both those steps at once, and it's fine, just do it one at a time. So check, we've done A. Now question B asks us to verify that the conditional and the contrapositive are both true. So let's start with the conditional statement, right? Which was if a number is a multiple of 10, then it is multiple of 5. So let's check that one out here first. Now you can use set notation here if you would like. I'm just going to use plain old regular numbers, right? So multiples of 10, right? 10, 20, 30, 40, 50, 60, 70, so on and so forth. Multiples of 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, whatever. I'm just writing you all a bunch of them. So if a number is a multiple of 10, then it is a multiple of 5. Is 10s in the 5s? Yes. Yes, 10's in there. What about 20? Yes. What about 30? Yes. What about 40? Yes. What about 50? Yes. Okay, so far it's looking true. Can you think of anything to disprove that? Is there a number that's a multiple of 10 that cannot be divided by 5, right? Are we so if P is correct, P is true, is there a false Q? No. No, I can't think of one. So in this case, the conditional statement is true. So now let's do the contrapositive statement. So if a number is not a multiple of 5, then it is not a multiple of 10. Now this one's trickier to do. And if you were to list out numbers, not a multiple of 5, oh, that's like 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, and so on and so forth. You don't have to do this, but if I were to do that, and then same thing. I list the not multiples of 10s. So if I take a number that's not a multiple of 5, and I check, is this not a multiple of 10? Yes, that's correct. A number that is not a number multiple of 5 is not a multiple of 10. So this is true. In this case, I'd be looking for a number in here that which isn't, right? And I can see here that every single one of these numbers, except for the 5 and the 15, is in there. So yeah, this one's true. What they do here? They did a Venn diagram, which I guess you could do. They did some notation, whichever one you guys look at. But otherwise, you guys are good. All right, so that's everything here. So let you guys get into that, and then we're done for this section.